Hello, today I want to show you an app which I've created using something known as Streamlit, which is a very quick way to build and share data apps. So before we go on to the details, let's just first see this app. I have created this app to show the different distributions in PyTorch. We have this app and the navigation where we have the home, the continuous and discrete distributions shown here. So if I click on continuous distribution, I have a drop-down menu to choose between uniform, normal, and log normal distributions. And I am plotting their probability density functions. In this app, can also hover my mouse on these values and I can see the x and the f of x. We can modify the lower bound and the upper bound in this case for the uniform distribution. Or let's say if I were to choose a normal distribution, you can see if I vary the mean, the distribution shifts toward the right. If I increase the variance, you can see how the distributions becomes more spread. I could have also used the log normal distribution, which you can see has support only for greater than equal to 0 values. We could have also gone and seen some discrete distributions. In this case, I have two discrete distributions. The binomial distribution, which is telling us the number of successes in n experiments, binary experiments, where the success or probability for each experiment in this case is 0.5. So therefore, we can see the maximum value is at x equal to 5, and we can modify the parameters and see how the distribution shifts. We could have also plotted the Poisson distribution with the rate parameter, and we can see the distribution shift according to that. Now, we want to build this kind of an app, and we will do this using Streamlit step by step. So we'll first go on to the terminal and check whether Streamlit is installed or not. In my case, Streamlit was already installed and I was using the latest version. So therefore, we are good to go. I will also show the specific repository where I have put all these details. So I have called this Streamlit demo, and I just want to show you the repository structure first. I have created the main app was under this home.py, but we'll not use this for now. For now, we will be looking into this folder called Sandbox, where I have created these different apps, version 1, version 2 till version 6, and then the first version of a multi-page app. This is to show how we can incrementally add more features to the app, as well as learning the different features and components of Streamlit. So if you have cloned or forked this repo, we can go to this repo, and I have already opened this up in VS Code. So we'll firstly go to the sandbox folder and see the app version 1.py. I am importing Streamlit as ST, and I'm importing torch, matplotlib. So I'm making a matplotlib plot initially. I put a slider on the mean, which goes from -10 through 10, and I put a slider, so Streamlit slider, st.slider, which is for the standard deviation going from 0.1 to 10 in steps of 1. And sorry, this is not the step of 1, this is the default value, and the default value for mu is 0.0. This is my regular PyTorch code where I create a normal distribution. So importantly, you can see that mu and sigma I've just defined as these variables or st.slider. It will automatically pick up the value which is currently present, and the remaining things is just regular PyTorch code where I create an X range object which is going from -10 to 10 and with 1000 such numbers in this torch tensor, and then I create my probability density function, evaluate at these X range values by calling the log prob and exponentiating that. And then as usual, I would just plot this figure with X and the PDF as the Y value. And the change here is that I call st.pyplot of PLT. And if I run this app, so the way to run this app is to go to the terminal. I am already in that folder. So Streamlit run sandbox app 1.py. So if you run this, you can see that it opens up an interface on your browser with localhost port 8501. This is giving you a very simple interface, which if you modify the value of the mean and the standard deviation, you can see that the distribution object created would change, and similarly the corresponding plot would change. So good thing about this is you did not really need to write any JavaScript code, which was the status quo. This was the main recommended way to create such apps a few years back. So this is the huge advantage with apps like Streamlit and Grad.io have now brought to the table. We also saw that in our app, we had a st.title, which is this particular PyTorch distribution that we have added. So this is the first version, very simple. I will just close this and let me also just kill this app. We will now build the next version. So here, if you can see that, I will also add some LaTeX and Markdown to the app because I want to, let's say, show the probability density function, just write it out in math. So first, let me run this and then let me show you the new changes which I have made. So as before, Streamlit run the folder name. This will again start the web app on localhost. In this case, it's again assigned the port 8501. So this app is the same as the previous one, but you can notice that there is a small change now that you have this text in Markdown and then you have some LaTeX math representation. So this is specifically done to show the capabilities. Now let's go back and see what changes we needed to make in the code. So everything else is the same. We can write some Markdown text and in Streamlit using st.markdown, and therefore if you can notice that I had this double star for the bolding, and then I've just written st.latex as a raw string where I've mentioned this fx equal to, so if I just write this LaTeX, it will get nicely rendered as we have seen here. So we have seen one additional functionality now in this app v2. Let me just close this and let me close the app as well. And now let's open the third version where we'll add some more changes. So in this case, we will also now so first let me run this again and show you the changes before I show you the code which enabled those changes. So now you can see that I've added this nice looking table which shows the different properties corresponding to this distribution, the mean, the standard deviation, variance, and entropy. These values will also change as I vary the slider. So therefore, it's a very nice summary of the different main properties. You could have put other things also like the different moments, the skew, kurtosis, whatever mode, etc., which are the different properties associated with the distribution. You could have also put the formula and then the corresponding value. This is to show the capability. So the way we created this table was, I firstly created a pandas data frame where I have the property and the value. So the property being mean, standard deviation, variance, and entropy, which is a list of strings, and the value being the corresponding values which we have as per this distribution. And then I just called st.table on a data frame. So therefore, Streamlit has this nice way of rendering data frames, which makes it very convenient because very often in a data analysis, we have the data in the form of data frames. Oh, before I will close the browser window, I will close this app and I'll show you the next version of the app. So here you can see that previously all the apps which I'd created, the plots were static. Now I have created these plots which are interactive. So you can see that if I hover my mouse around them, I can see some values. I can also pan in this case. I can also just open this graph in a full screen mode. I'm showing two different ways of doing this. The first, I will be showing this using something known as line chart in Streamlit. The other is using Plotly. So here also you can see that I have a X and FX, and I have this different capabilities of zooming and panning. So these different interactive plot capabilities we have now added to Streamlit. Let's see what we needed to do in the code to enable such functionality. I'll open the version 4 of the app. So we had this chart data. I have created this new pandas data frame containing X and the PDF. And then I call this st.line chart, where I specify the data frame, and then what is the X column, what is the Y column, what is the X label, what is the Y label, and I'm also using use container width equal to true to maximize the width of this plot. So this is how we can use Streamlit line chart. The next one, I am using Plotly, which I will be using going forward also because of the nice interface it has, a lot of customization that it offers. I create a new plotly.graph object, and then I add a trace to it. You could have added multiple traces. In this case, I have a single trace, which is a scatter plot with X being X range, Y being the PDF, and I'm drawing lines. And I have a hover template where the X value is taken with 2 decimal places. Then I have a new line, and then the fx is showing the Y value which has been taken. And then I'm just putting the X and the Y in the axis. And then instead of just previously, I had put st.py plot, and in this case, I've put st.line chart. So for Plotly, I put st.plotly chart and fig. So this is a very powerful capability because it allows us to hover, understand the data better as opposed to the static graphs. Let me now show the next version of the app. So the purpose behind showing these apps is how we can start from scratch, incrementally learn new features of Streamlit, and then also make the app very close to the final app which I showed. Version 5 of the app. Okay, this is, if you can now notice, it looks visually a lot cleaner. The main difference here is that I have moved some of these things to the left hand side, which is in this case called the sidebar. So I have two main views here. One is the sidebar where I have the controls, and the right hand side I have the plots, or I could have also added the maths, etc. So you can notice that everything else remains the same. You can also see the selected parameters and the properties can be shown here. This is often a very commonly used paradigm in Streamlit like apps where the controls are in the sidebar. To enable this, let me show you the app version 5. So you can notice that I have this sidebar whose header is the distribution parameters. So whose header is the distribution parameters. And in the sidebar, I have the slider. So previously, I was just directly putting st.slider. Now I have this slider in my sidebar. So st.sidebar.slider, and then I've put the mean and the standard deviation. And everything else remains the same because then I can directly get the mu and the sigma objects. And I'm also writing st.sidebar.markdown. So you can notice that previously when I was just directly writing st.markdown, etc., I can now just write st.sidebar and then have the sliders, then write the markdown. I can also write some other things like the mean, standard deviation, variance, and entropy. And my main plot area remains as it is. So I just had probability density function written here, and then I added the same plotly figure. Let's close this app and let's open the next version of the app. Okay, so this version is now very powerful, very close to the final version that we wanted. Now I have on the sidebar, I also have this drop-down menu to choose between the distribution, whether it should be the normal or the uniform. You can see the changes happening. So once, firstly, I've set to normal, the PDF for normal distribution is plotted. You can also see probability density function for normal distribution. Now let me, without changing the parameters of normal, just move to the uniform distribution. You can see that this title has changed, as well as the arguments have changed, and correspondingly the PDF plotted has also changed. So this is now very close to the final version of the app that I had. And it's important to be able to choose between different distributions. Naturally, we'll expect the code would have now become fairly sophisticated. So we'll have to open app version 6. So importantly, if you noticed, that my sidebar header still remains the same, distribution parameters. Then I have to put a drop down. So I put a drop down in the sidebar, which is a select box between with the text being select distribution and the text options being normal or the uniform. And then I can put an if else. If the distribution type is normal, then I create everything corresponding to the normal distribution. So if it's normal, I create a slider for mu for standard deviation. And then I also put my selected parameters mu, standard deviation, and entropy. So you can see that if the distribution type is normal, I then create mu, sigma, and as a sliders, I create the distribution based on mu and sigma. And then I find my PDF, evaluate my PDF on X range, and then I can write and mark down the different parameters. Otherwise, if my distribution type was uniform as selected by this type variable, I'd create two different variables, A and B, and I put them as the lower bound and the upper bound. And I also have these checks. If A greater than equal to B, then we put an error, etc. And everything else just remains the same. The standard way of evaluating this PDF and the main plot area still remains the same. So we have now looked at this app, which is now very close to the final app. Let me close this and show you the next version of the app. So in our folder structure, we only had till V6, but we also have a multi-page app where we have a home.py and we have the pages folder. So in home.py, I have not set much content. In the pages, I have created a discrete.py and a continuous.py. So let's just view this app, this specific one in the sandbox multi-page one. The home.py will just show you the page config, and then it has put some markdown content. Let's first run this. So we have the sandbox folder. In that we had the multi-page folder. In that we had the app called home.py. And now in this, you can see that I have structure which is looking close to my final structure. I have a continuous and I have a discrete page. We can call these as different pages. And within these page, we can choose, we could have also chosen a drop down. In this case, I just have a radio button where I can modify these parameters. So this is now very close to the final one. There are few small changes which are there, which are better in the final version. But first, let's see what this app does. So firstly, whenever we have, like in this folder structure, we had the home.py, which becomes a main app. And then we had this pages folder where we have continuous.py and discrete.py. Let's just open continuous.py. Here you can see that continuous.py is fairly similar to the previous app which I had. We have a sidebar. Previously we had a select. So previously we just had a select box. Now we have just put a radio button. Everything else is pretty much the same. So the idea is that we can put all the continuous distributions here where we put the sidebar, and based on the distribution type which is selected as per this variable, we can then roll the different versions of, so the different arguments like mu sigma for normal and A and B for the uniform distribution, and the remaining things are similar. Similarly for the discrete distributions, so we have a separate page where we have a drop, we have a radio selection between Poisson and binomial, and depending on the distribution type, we expose the different parameters like lambda for the Poisson distribution and NNP for the binomial distribution. So thus far we have achieved almost all of the functionality which we wanted, but what I felt at this point was that this whole code was not very easy to extend. If I had to add another distribution, it would be fairly sophisticated. This would keep getting bigger and bigger, these pages. So therefore, I will close this app and I will show the main app now on GitHub. So it's not in the sandbox. it's the home.py, and we can see that the home.py is similar to the previous home.py. I have another file called utils.py, which contains some utility code which I will be using, and it has a pages folder where I have continuous.py and discrete.py, and there is another additional folder called config. So we will first be looking at the config folder to understand what I did to make the whole app more extendable. So if we go to the config folder, we can see that I have created this nested dictionary. I have a config continuous.py. So this nested dictionary, I put in the different distributions, the first one being uniform. So I'm specifying that for uniform, the parameters are A and B, and I've specified what I would want in the sliders. Similarly, I'm specifying how to create this distribution object. I'm also giving the support or the ranges of values which it can take. Similarly, for the normal distribution, I've specified the parameters being mu and sigma, and I've specified the distribution object. I've put here distribution support being none. So here support actually mean the support constraints. For uniform, we want the support to be between A and B, and for normal we don't have any support constraints. For log normal, we want the minimum to be 0. So it should technically be not called support, it should be called support constraints or support min max constraints, something like that. For normal distribution, we have nothing. So the idea behind doing this configuration was so that we can now decouple the specifics of the distribution from the code that we are writing. And tomorrow, if we want to add another distribution, it's fairly quick. You just need to add another key and the corresponding set of values corresponding to the parameters, distribution, and support constraints for that specific distribution. Similarly, for the discrete distribution, I have created this config file where I have the binomial and the Poisson distribution, specifying the parameters, support constraints, and the distribution object. Now, we want to be leveraging these configurations, reading these configurations in our main app. So we'll go to the pages and open this continuous.py. You can see that this is significantly smaller than the previous continuous.py that we had. One of the important reasons is that because the configuration has been just taken away and been put in this config file, and I've put a selected dist object on the sidebar where I'm selecting between. Now I can just also give list of continuous distributions.key. So it will then expand out, see the continuous distributions and expand it out. So the keys are uniform, normal, and log normal. So therefore, I like this version of the app. Tomorrow, if you increase anything, add any distribution here, it will automatically get reflected in the select box. My parameters are, once I've selected a distribution, so the continuous distributions object, selected distribution, and then the parameters from the distribution key. So then it will just look at the parameters here. And once I have that, I can also create the distribution object. I can figure out the support, and then I'm just having some small functions to figure out the support for the specific distribution. And then I have this X range, which is -10 to 10, 1000 such values. I have added a function called compute PDF and then a function to call plot PDF. So the compute PDF function takes the distribution object, the range over which you're plotting, and the support arguments that you have. So this function is defined in utils class. This is quite a simple function. We just first figure out the PDF, we just set it to all zeros, and then within the support we put the values. This is just ensuring that the PDF is 0 outside the support and it is defined as per the distributions PDF function within the support. So the reason to do this is outside the support, torch distributions would give an exception if you try to validate the PDF. So similarly, we have the plot PDF, which is what we'd seen earlier, but we've just abstracted it out so that it's easy. We don't have to repeat this code. Similarly, for the PMF, so in the PDFs, we were plotting the scatter plot. In the PMFs, we are plotting the bar plot. And the other things are fairly similar. So similar to the continuous.py, I have the discrete.py. Sorry, not this one, this one. where again you can see that the code is fairly short in length because we have abstracted out the configuration in a separate folder. So we can now run this app. Let me just first kill the previous one. Now this particular app is on the root directory itself. So this is the app which I had also shown, which was deployed in Hugging Face. You can see that I can choose between the different distributions and I can vary the parameters, and you can see the modification. I'll also leave a small exercise for the viewers to try and figure out and submit a pull request to address that if needed. So let me reduce the lower bound. Let me make the upper bound greater than that. You can see that I get a value error. So ideally, we do not want this kind of an error. We should have a better way of either not allowing these values or giving a better error message. So thus far, we have been able to see how to create these different apps, and we have been running them locally. But here, if you notice, the URL is on huggingface.spaces. So how do we upload them there? We will now take a quick look at that. Importantly, what I have also shown here is that I have created and uploaded this app on GitHub, which is what we've been seeing thus far. So on the README page, I've also specified the instructions. So locally, I had all the things installed, like I had Torch installed, I had matplotlib, plotly, all of those things installed. But let's say if you are to upload this to Hugging Face, it has to have a way to understand what are the different dependencies that you need to install. So therefore, we also need to mention a requirements.txt file where I've put Streamlit, Torch, Plotly, and Pandas. So these will get installed before the app is built on the Hugging Face page. There is also this particular set of things which have been specified in the README. We do not want to modify these because these have been provided through the Hugging Face spaces. This is the YAML configuration which we need to specify, which is the title, the some emoji, the colors, etc. We've also specified that the main file, app file, is called home.py, which is in this root directory home.py. And the remaining README is the other instructions which I've set. So in order to run this on Hugging Face, you'd have to create a new space, which I'd already done. So if you are new to Hugging Face, you have created a new account, you can just go to spaces and you can create a new space, something of this like. You can specify the name that you want. Importantly, you'll have to specify the space SDK. In our case, it was Streamlit. So let me just give some dummy name for now. And if I do Streamlit and I create a space, you'd see that this dummy name has been created. And you can notice that it is providing some Git-like features here. So interestingly, when you are creating a Hugging Face space, you can also host your repository on Hugging Face spaces as a Git repository. So you can, for example, if I were to start from scratch, I would clone this. I would then put some basic app.py. Importantly, the SDK specifications have to go as per what I have shown here. This needs to go in the readme.md. This is a way for Hugging Face to know that this is my app file, this is the SDK version of Streamlit that I'm using. I'm not using for Grad.io or any other things. Hugging Face would allow you to create various different kind of spaces. So for now, and they also mention you can specify the requirements.txt to mention all the dependencies, etc. And the Streamlit package is pre-installed with the SDK version which has been mentioned. So what I did was to ensure that I put the requirements.txt in this folder, and I've already shown how to run this locally. Now, importantly, I had committed this repository to GitHub. Now, there has to be a way in which this repository is pushed to this space. As you can now see, this space, or this, think of this as a GitHub repo, this seems to be empty. So I want my content to be also pushed to the GitHub repo which I want. So to this GitHub, so to the space which I want, Hugging Face space which I want. So if you notice, this is the one where I was running. It's called probability distributions. Here it is matching the structure which I had. This is the exact same repository which I was showing on GitHub. So you can see config pages, sandbox, etc. And you can see the same thing here: config pages, sandbox, git ignore, home.py, readme.md, etc., etc. So you might see that both of these are pointing out to the same content. There's a similar content over here, which is exactly what I wanted. I could have created a Hugging Face space and I've used that as my main Git remote, but I'm not doing that. I want to keep GitHub as one of my remotes, and I want to keep Hugging Face as one of my remotes. So for that, what I did was I added another remote. I added Hugging Face as also one of my remotes, which I did using this specific command where I add, this is the name of my remote, which I'm just calling it space, and this is the URL which I'm specifying. And once I've done this, you can see that because I've already done this. So if I specify, I check the remotes. So if I was pushing only to GitHub, then you'd see just this origin as the name of the remote and the fetch and the push. Whereas because I've also created another remote, which I'm calling as space for corresponding to Hugging Face spaces, and this being the remote URL with fetch and push, you can see these also being mentioned here. So this is interesting. If you've not seen this earlier, you can have a same local Git repository, but you can have multiple remotes. Now, if I go back to the README, I also want to be pushing my content to both of these so that they remain in sync. And then if I make a change, it will get updated on the Hugging Face app as well. So in order to show that functionality, let me just go to the home.py and let me just add some simple content made on 1st of March 2025. This is just some dummy text that I've added. I will just go to my Git on the terminal. I will just modify the changes, just add a simple message, some dummy text. Now I will do git push all. So you might have not seen this git push all command earlier. So interestingly, if you notice, I have pushed my content to my GitHub repo. I've also pushed the content to this Hugging Face spaces. So in one command, I've pushed my current content to both of these, my updated commits to both of these via this command push all, which is a simple alias that I've created. So I've created this alias push all, which does push origin main and then git push space main. So it's pushing, this one is origin is referring to the remote corresponding to GitHub, space is corresponding to the remote corresponding to Hugging Face spaces. So therefore, whenever I make any change, these will be the things which will change. Now quickly, let's go to Hugging Face and see. So firstly, you can see that this new commit has appeared. Similarly, on the GitHub page, you can also see that this new commit has appeared. Whenever there is a new commit on the Hugging Face app, so it starts showing all of this build process. So in this build process, essentially it will download some image, it will install all the dependencies, the requirements.txt, etc. it will install. After that, it will run this app on some particular port 8501, and that is what you end up seeing here. So here I think currently it did not need to make any changes because this commit was not changing anything in the app. So therefore it just used the same version of the app. But if you were to make any changes in the app, you might see that the whole build process is repeated. So this was to show you the functionality of Hugging Face spaces. Okay, actually there's another thing which I wanted to show. So if I run this app, you can see that the app is working perfectly as we would have liked. But if you can see that this is not running in the full screen mode, which I was earlier showing. This is running in more like the full screen mode. So the way to do that would be to go and click on this embedded space, and then you get a direct URL. So let's actually just try and see if we were to make some changes to the home.py. Does it trigger the, oh, okay, so I think I made change to the wrong home.py. So that is why we didn't see anything. So if we were to just add made on 1st March, let's use some simple dummy text and push all, and let's see if this because of this, if we see any new build, you can now see that it's called building. So we can go to the logs and you can see the entire build process. On GitHub, you can see that this new commit has quickly appeared. It has also appeared on the Hugging Face spaces, but it will now just do the entire build process. And you can also see the logs. Okay, so this was to show you the functionality of Hugging Face spaces. You can create very cool apps. I also showed an interesting way where you can maintain the main repository on GitHub, and then you can create a Git alias called push all, something similar to that, so that you can push to multiple remotes. In this case, being the GitHub remote as well as the Hugging Face remote. You could also be smarter about this and create some GitHub actions which would correspond to GitHub workflows folder here, which would then be triggered on the GitHub servers. Whenever you make a push, they would automatically sync it up with the spaces remote. But I have not done that. I've done another way, which is just to push my changes to both these remotes. Thank you.